All right, welcome back. It's Thursday. Good Thursday morning to all my 8J scientists there. Today we are going to do another simulation from Phet about our roller coaster in our skateboard park. Just to review though, yesterday we talked about three important words that we're going to be using a lot today. Energy, the ability to do work. How things can make things change or move, and think about just your body, how you need energy for that to move. We need energy for cars to move. Our electronics, they need to have energy to do the work that we want them to do. And there's two basic types of energy: kinetic energy, energy of motion. Anytime something's moving, that has kinetic energy. Potential energy is the stored energy based on a position it has in a field, like a gravitational field. So let's get started. So for day 4, we have one slide today. It says, first of all, review the vocabulary. Done. Number 2, it says, click here to activate the Phet Simulation. Let's do that now. We're going to go back to the intro like we were at yesterday. So I'm going to click on that. Here we go. When you get here, again, remember, you're going to select all 4 of these boxes here: the pie chart, the bar chart, bar graph, the grid, and the speed. We're going to use these all today. And then we're going to click on the L ramp here instead of the U ramp. I'm going to pause and put our skater right there at the top. Okay, so you can see where we're starting at with a lot of potential energy. Potential energy is blue. Here we have, again, just looking at in the pie chart, it's all blue there, and her speed is at 0. She's holding this position. Let's go back to the slide presentation here and see what's next. So step 3, place your skater at the top of the slide, the L track, and let her skate. Make sure all the white boxes are checked. Pay attention to what is happening to the bar graph, circle graph, and her speed. So let's do that right now. Going back here, we're going to just go through this a few times. Notice how these change. Okay, the speedometer will change. Here we go. And there she goes. And you can see how, if you look a few times, pay attention to each of the different charts and the speedometer at different places and different locations. Today what we want to see is what relationship do these things all have together. So I'm going to put her back up there, ready to go. Back to the slide presentation. Click number 4 says click here to answer some questions regarding your observations. So let's go there, open our form. Remember, forms are how you tell me what you've learned, and this is how you get your grade. So make sure you do all of the different forms that are on this, and by doing that you'll be able to follow your progress in the skyward. So here, put your name, full name, first and last, please. And then it starts off with the question: before you send your skater down the ramp, where do you think her speed will be the greatest? Okay, so tell me what you think right here. This one is a participation question. By doing that, you'll get all the points there. Don't forget this part right here, though. Tell me top, middle, or bottom, but then tell me why do you think that? Why is how you get all the points there? All right, next part. Place your skater high on the track, like the picture below. Use the bar graph, the circle graph, and the speedometer to describe the amount of kinetic energy, potential energy, and speed the skater has. So in this case, we're going to be looking at all 3 of these, and you'll have to probably do this about 3 times to check. Kinetic energy at the top, is it low or high? Potential energy, low or high? Speed, low or high? Now make sure that you only have one of these selected in each row. Only one should be selected there. So we'll go back and I'll hit play. So you're looking here at the top, this position. What do you notice? Okay, after you've made your selections there, the next question says, as your skater travels down the ramp, pause her in the middle. So about this location right here, it doesn't have to be exact. Pause her in the middle of the track, like the picture below. Use the bar graph, circle graph, and speedometer to describe the amount of kinetic energy, potential energy, and speed the skater has. So we'll do that now. There we go, about this location. Like I said, it doesn't have to be exact. So somewhere in here, what do you notice about the speed, kinetic energy, and potential energy compared with what you said up here? Okay, how does it compare? Is kinetic energy lower or higher? Is potential energy lower or higher than what it was? And is the speed lower or higher? Only one in each row, please. And then finally, as your skater travels down the ramp, pause her at the end of the track. Like the picture below, use the bar graph, circle graph, and speedometer to describe the amount of kinetic energy, potential energy, and speed the skater has. Okay, so we'll do that. Switching back and pause. Anywhere in here is fine. So look at the speed, kinetic energy versus potential energy, and over here on the pie chart. Going back, compared with where she was in these last two questions, has her kinetic energy lowered or risen? Same thing with potential energy and speed. Make one choice for each row. Then right here it says, based on what you've seen, let me start that over. Based on what you've seen, you can say that, and notice right here, select all that apply. Okay, there's going to be multiple answers for this one, so please read carefully, look at your answers at the top, and then make what do you think are the right answers here. There's going to be more than one, multiple answers. Finally, at the bottom, know that now that you have seen your skater at all three places on the track, where did your skater have the greatest speed and why? Okay, pay attention to that why. Explain that to me. Use the ideas of kinetic and potential energy in your explanation. So for this part right here, I'm expecting about 2 sentences. You're telling me where she had the highest speed and why do you think that. If you use those words, kinetic and potential energy, in your explanation, you get all of those points. All right, when you're done, you'll hit submit. And then let's go back to our day 4 slide. It says, now that you're finished, complete and finish any work from days 1, 2, and 3 that you may not have been able to finish. So get those all turned in. Then you are all done for the week. Tomorrow, Friday, is a day off, so you don't have to do any work on that day. And I'll see you back here next Monday. So have a great weekend. Stay safe and stay in touch.